have considered the role of chemical bonds during a chemical reaction. Bonds of the reactant chemicals have to break, which requires energy, and bonds of the product chemicals need to form, which releases energy. We're going to shift our perspective to a more microscopic level and consider the bonds that break and form in more detail. The collision theory states that the energy required for bonds to break comes from the energy of collisions between reactant molecules. Also, the orientation of colliding molecules is important. Let's take a look at the reaction between an ozone molecule, which has 3 oxygen atoms, and a nitrogen monoxide molecule, which has a nitrogen and an oxygen atom. To form an oxygen molecule, which has 2 oxygen atoms, and a nitrogen dioxide molecule, which has 2 oxygen atoms and 1 nitrogen atom. Since the nitrogen atom bonds with an oxygen atom, the orientation of the collision requires that the nitrogen side of the molecule collides with the ozone, so that a nitrogen-oxygen bond can form. If the nitrogen monoxide collides with an ozone molecule and the oxygen of the nitrogen monoxide collides, then a bond won't form and a product won't result. So collision gives the energy required for a bond to break, but the orientation of the collision is also important so that product bonds can form.